Hey you guys, I hope you had a great break. This week we're going to look more into our probability, which is the chance that something can occur. This week we are going to be using a lot of experimental or estimating. So sometimes we'll have actual numbers to go by, and we'll like to use proportions. So I've added a proportions video to remind you what that is. We'll also be talking about estimating. Estimating, remember, is finding one without all the number information, but what seems like it would be our best answer. So we're going to use a couple of examples. I've got 4 for you that I really want us to look at and kind of dissect to make sure that we understand what they're asking us so we can see the difference between that estimating and that experimental. So when we look at number 1, it says we have a spinner. So we have black, red, and green. They all appear to be the same different size. They all appear to be the same size, which is very important for us to look at here. So black looks the same size as red, which looks the same size as green. They all appear to be proportional for the same size. So it says which tally chart shows most likely the results of 30 spins. So I did 30 spins, which we can assume, so we're estimating, we're assuming that I'm going to land on black the same amount of times as red, the same amount of times as green, because they're all the same, so I have the chance to land on them all the same amount. So that's roughly, if I were to split 30 and divide it by 3, I get 10 for each one. So 10 black, 10 red, 10 green. So when I look here, I have 4 different type of tally charts. Well, this one says that red just goes all the way, it gets almost all of them. Well, red doesn't look bigger than black or green, so we can assume that we shouldn't land on red more than we land on black or green. So that one can kind of be taken out. When I look at B, they all appear pretty even. Remember, 1, 2, 3, 4, the line going across means 5. So 5 plus 5 makes 10. 5, and then 1, 2, 3, 4 makes 9, and then 5 plus 5 is 10 plus 1 makes 11. So they all appear to be roughly the same, kind of like that 10, 10, and 10, which I'm assuming because they're all even. So I'm not going to cross that one out yet. Right here, this one's saying that green is only getting 2. The other 2 are equal, but the green's only getting 2, which means green would be a very small sliver compared to black or red. Black or red would be equal in size, and green would be a small sliver. That's not what I have here. Once again, it looks like black should be a larger section, and red and then green should be the smallest, but that's not the case. They're all even. So my answer for this would be B, because they are all appearing to come up the same amount of times, which makes sense because all of my sections appear to be the same. So they all are the same size, so I can assume that my chart is going to show that they're all going to be the same. Let's look at the second one I have for you. It says, if the spinner is spun 60 times, which color would you expect to stop on about 20 times? Well, I can look and see that this is kind of broken up into 4 main sections, and yes, this one's broken up even more. So if I take 60 and divide it by 4, I get 15. So I can assume that this section is going to be 15, this section is going to be 15, this section is going to be 15, and this whole section is 15. And if I were to take this and I were to divide it by 2, that means I have 7.5 here and 7.5 here. So when I look at this, I can assume 20, well I know 20 is bigger than 15. So it means that it has to be more than just one section. So when I look, red is not only here, but it is also this little section. Green is only a small sliver, yellow is only that 1/4 mark, and blue is only 1/4 mark. So I can assume that red is the only one that's going to be done over that 1/4 mark. So we want one when we break it up into 4 sections. Yes, this one has 2 in it, that's why I broke it up even more. But when I break it up into 4 sections, that means each one of these sections is about 15, and I want something over that. All right, looking at number 3. Number 3 states, if there are 530 employees who work for a retail clothing chain, the table shows the absentee distribution for one store. So I'm looking at the absences for this store. It tells me that I want to know for 530. However, this does not add up to 530. We have 6 plus 2 plus 1 plus 3 plus 8. When I add all these up, this gives me a total of 20. For this chart, my total is 20. But I want to pretend like I have a chart that has 530 for it. So if I want to make a reasonable prediction, remember, assumption, a prediction, I'm trying to figure out what's going to work for my Monday. I've already known my Monday, and I know my total, and I know my total for my other chart, which means that I can set up a proportion. Remember, a proportion says this equals that. So I'm going to use my chart data first. So I'm going to use Monday. Monday is 6 over my total of 20. Since I want to predict how many for my absences for Monday from 530. I don't know that yet. I'm going to put an X. But I do know that I had 530. So I have my proportion. My chart equals what I actually probably have because I'm still predicting. So cross multiply, 6 times 530 makes 3,180. 20 times x makes 20x. Then I have to get x by itself, so I'm going to divide both sides by 20. This cancels out. 3,180 divided by 20 means x equals 159. So estimating a prediction, because Monday seems to be one of the most missed other than Friday, I can assume from my prediction of the original numbers of just those 20 days, I'm going to have 159. So you have to look at your chart data, and then you have to try to set up a proportion for what you really feel like you're going to have. Last one. It gives me this data, it gives me this chart, and A takes up a very large chunk, which is why it doubles the rest, which makes sense because it's double the rest. And it wants me to, then using this experiment of 25 times, so all of these tallies add up to 25. It wants to know what is the experimental probability of the spinner landing on A. So I'm only going to work with A here. Not going to have to do any more than that because it only wants to know A for this information. So I know that I have 5, 10, 11 tallies. I have 11 tallies. And I know I did this 25 times. So I'm going to write this as my probability as a fraction, 11 over 25. When I do 11 over 25, which remember this is a division symbol, but fraction means division, I get 0.44. But this is a decimal, so I need to do one more thing to it, and that is to move my decimal to make it a percent. I need to move it 2 places right. 1, 2, making this 44%. Hopefully these helped you break down some of those questions that you're going to be seeing this week on your assignments. Hopefully this helps you see and put them into a little bit of perspective that when you have things that appear to be the same amount, they're going to end up looking like they're going to have the same tallies. When you have a chart like this and it takes up half, then you're going to expect it to have more tallies than the rest because it's larger. So you really want to make sure that you look through these questions carefully because they are easy when you break them down, but they do seem tricky at first. Hopefully this helps, and